Hello everyone. In this video, we will be discussing on procedures and macros in 8086 microprocessor. What are the different procedures? What are the advantages of procedures? How to call a procedure and how to call a micro and the advantages of macros and disadvantages of macros. And lastly, we'll be discussing on the differences between a procedure and macro. Coming to the first one, the objective of this lecture is to help the students to gain knowledge in procedures and macros and the design in 8086 microprocessor programming. So the procedures will be of, first of all, procedures are of two types. Before going to the types of procedures, first, what is the definition of a procedure? What do you mean by a procedure? Procedure is nothing but a subprogram. The subprogram or a routine of instructions. If you are having a set of instructions which are to be repeated some n number of times, so those instructions are being written at one particular location, and they can be called using of procedures. The assembly directives used for procedures is PROC. These are procedure assembly directives which is being used to call a set of instructions. These are the set of instructions. Procedure is nothing but a set of instructions which are being called a number of times, and these set of instructions can be called using of an instruction called CAA. And in the procedure, once a procedure is been written, it could be completed with a return instruction. So you would be having a procedure would be given with a call in the mainline program, then it would be ended with a return. So as for this example, this been considered, the mainline program is there, it has been getting executed, it is calling a procedure. The procedure starts from here and it ends till the last, and once the procedure is completed, it sees the return in the one, it will come back to the mainline program. So procedures are of two types. One of the types is recursive procedure. So the recursive procedure is a procedure which calls itself. Every time it will be calling itself. That is a recursive procedure. Then comes is a recurrent procedure. So what, for example, over here recursive procedure, if the main procedure is been main program is been running, it will be calling a procedure. So this will be running to the subprogram or the procedure program. When one point, it will be again having a call instruction. So again, the same procedure is being called. The same procedure is being called. Again, it will be executed. Then it may be ended or it may call one more time. It will go repeated all. So once every time calls the same procedure, it is nothing but a recursive procedure. And once it reaches the n value is equal n is equal to 0, it come back last but one, then it completes the set of instructions, this one, then it completes the set of instructions, this one, and then come back to the mainline program. So the flow would be like this way: the first one, mainline program, then the first one procedure is being called. Again, once it sees the call, it will go for the next procedure. Once it sees a call, it goes to the next procedure. It completes the total program at the last, it is equal to 0. Come back to the main program, that sets the complete the set of instructions, come back to the next one, complete the set of instructions, come back to the mainline program. This is a recursive procedure. Now going to the next one, recurrent procedure. Recurrent procedures are the procedures like, for example, the mainline program is been running on. So once the mainline program is getting a call in a program, the subprograms are the when let's say procedure one is getting executed. This is the program or the procedure one. This procedure one is been getting executed. Then procedure one is calling another procedure. Procedure two. This procedure one and procedure two are different. So when the procedure 2 is been executed half, again it would be called procedure 1. Then procedure 1 will be executed at this point, it will go there. So this repeats after this one, again it goes for the completing it up, and once it procedure one has been completed, it will come back to the procedure two. It will complete it over here, come back to the procedure one. So it is like this. Procedure mainline program is coming. Process of program. Okay. Procedure one. Procedure one calls to the procedure two. Procedure two calls back the procedure one. Now, this procedure one would be once it completes, come back to the procedure two will come back to procedure one. So this procedure, so here what happens is that this procedure one, from the procedure one, it come back to the procedure two. Then the procedure two completes it up, it come back to the procedure one, and it again complete this one. Then it come back to the procedure mainline program. The mainline program will be executed. The reiterant procedure. Then in your how you can follow or how you can pass out parameters in the procedure. Parameters is nothing but the values of some set of conditions we can follow it when you are sending up in the procedure. So you can send it up procedure parameters using of registers. Either you can put the parameters in the registers and you can send it up, or by the dedicated memory, or you can point out a pointer and the help of an instrument. One after the other, we'll see parameters flowing in a register. So what I'm doing is that here I'm passing out values by using a value into the BL. So I'm taking in a value which has been passed from here into the BL into the AL. Again, I have gone to the squaring, and the value is there as a main number going back into the BL and sending back to the main right program. So now here I'm using a register BL for passing on the values from the mainline program to the subprogram. This is a first one. The second one, dedicated memory. So here, when you're in a microprocessor 8086, when you're using NASM, we will be defining certain memory locations with specific names. Like the name is given for this is the memory space where given as num. Then I can use those. I can define this one num over here memory space. I can use those memory space over here by taking a. So this is a dedicated memory location dependent. So mainline program will define it. You can define two pointers, source index and destination index. For those source index and destination index are the pointers in the memory location that could be pointing out over here in the memory, and you can read the data or enter data into that one. Or stack. So here we'll be going for pushing a values into the stack. Then here we will be correcting back by using a for CX. So when you put here, so intermediate or the most wherever you can go. Here it should not be there. It should be over here. So this is about sending a parameters using of stack. These are the four ways. These are the few of the advantages of a procedure. So it saves the memory. It, the program development becomes easier. Debugging of error program is easy and reduce the program time. So every time these are the advantages when you are using a procedure. So every time you need to use call and return. That should be very much specific. And when it is a control jumps from the mainline program to the subprogram, it takes a little bit of more time. So that's the reason. This is another disadvantage of a procedure. And next one is that for small group of instructions, linking and returning back is about data. These are the disadvantages. And when you look for the micros, micro is a length of a program. This is also a subprogram which has been written over here. Once a micro has been written, a set of instructions are directly following on to the mainline program. So it is like once you define in the micro 12 to 13, and just say micro 12 to 13, it will be tell you the length of statements. Whatever the statements are there, it will be appearing in the statement. So this is the part here. Yeah, suppose 10 lines are programs are there. 10 lines of program are there. You doesn't want to write every time those 10 lines. So what you can do is that you can define as a micro. you can define as a micro, and you can use those 10 lines into the main line program just by typing the micro name. Automatically, the total it would be ended. And one more thing, to end a procedure, we write as end P. And to end a micro, we write as end M. These are all these things are used in a Microsoft Summary. So these are the advantages of Amazon and these are the disadvantages of the micros. And lastly, this is very, very important is that the difference between a procedure and a macro. What are the different parameters we are taking into consideration? One of the other we'll see this uh, procedures are a group of instructions can be repeated. Let's say there is one good thing about the procedure is that you have written very lengthy program. So this program can be used as a procedure and it can be repeated a number of times. It makes it very easy for us. For longer programs, and these are the disadvantages of the procedures. Procedures are used for, these are basically micros. Micros are used for small group of instructions to be repeated. Object code is generated only once in a memory. Object code is generated every time in a memory. Say, whenever you write micro, the code is being again written back. Meaning. So that's the another disadvantage of the micro. Calling written instructions are used to call procedures and this is not an advantage. Procedures can be just by writing its name. Micro can be used by just calling its name. That is a better advantage. Next, object find is used is very good. Object find is becomes somewhat lengthy. This is not an advantage. So directories, procedures, and NP are used for defining the procedure. This is for starting of the procedure, end of the procedure. Similarly, micro name, micro name of the procedure for starting of micro, and end ending of micro are used for ending. So here, more time is required for this execution. This is a disadvantage, and less time is required for the advantage. This is then our general definition defined as a micro procedure name procedure and end of the procedure name. What is the procedure with the ending C? Micro, micro, name, and end. For example, we can go for an example, addition procedure near. There would be two types of procedure. So near procedure is the procedure which is in the same segment. The procedure is in other segment is an R procedure. Similarly, you would be having a micro, if it is in a remote in a near micro or you see that we are micro itself. So this is overall the difference between a procedure and micro. Thank you for watching this video. I hope students will develop a microprocessor, integrated microprocessor program by including the subject. Thank you everyone for watching this video.